Good morning, students. Today I am going to explain about fifth unit, that is jet transforms. Jet transforms syllabus में inverse jet transforms, properties, damping rule, shifting rule, initial and final value theorems, convolution theorem, solution of difference equations by jet transforms. This is the syllabus we have in fifth unit, one part. Okay, part B. Part A basically Fourier transforms. This is jet transforms. Part B, half of the part of the fifth unit. This is okay. Next one, jet transforms. The technique of jet transforms is useful in solving the difference equations, digital signal processing, okay, and digital filters. That means in your core subjects, in these topics, we can use jet transforms. Okay, we will use jet transforms. The jet transforms have properties similar to that of Laplace. Laplace and jet transforms both are similar. Simple difference is there. Okay, little bit. What is that? Is the main difference is Laplace transform defined for functions of continuous variables, whereas jet transforms defined for functions of discrete variables. Continuous variables means continuous at time. Okay, continuous with respect to time. Discrete means different intervals, different instance of time. Okay, that is the difference in jet and Laplace. The development of communication branch is based on discrete analysis. The jet transforms plays an important role in the field of communication engineering and control engineering at the stage of analysis. The jet transforms plays the role in discrete analysis as Laplace transforms plays the role in continuous systems. Okay, ma? Next, jet transforms. Consider the function. Basically, in Laplace, we have taken f of t. Here we are taking consider the function f of n, defined n equal to 0, 1, 2, 3 like this. Then the jet transform of f of n is jet transform of f of n is equal to, here we are using summation, okay, discrete summation, sigma n equal to 0 to infinity. In the Laplace we have used what is that is integration with respect to t, n equal to 0 to infinity f of n z power minus n. Whatever the function they have given here, you substitute in this sigma. Okay, if the right side of the curve is convergent, then we write z of f of n is equal to f of z. Okay, after what is that is apply the sigma n, sigma, expand sigma and substitute n equal to, you will get only in terms of z. Series you will get in terms of z. That is called function of z. The inverse z transforms is written as z inverse of f of z equal to f of n. Okay, in Laplace you just remember what is that is in Laplace, what is that? L of f of t equal to f of s. L inverse of f of s equal to f of t. Okay. Whenever z of f of n is equal to f of z. Okay. Expansion of some functions. Basically, simple formulas. These are simple formulas. 1 plus x whole power minus 1 equal to, here base and power both are opposite in sign. 1 minus x plus x square minus x cube and so on. Both are same, all plus terms will come. Okay, 1 plus x whole power minus 2. Alternate plus minus 1, 2, 3, 4 are the coefficients. 1 minus x whole power minus 2 is all plus terms. Okay, 1, 2, 3, 4 that are the coefficients. E power x expansion 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial like this. Log of 1 minus x, minus of x plus x square by 2 plus x cube by 3 and so on. Log of 1 plus x ma, alternate plus minus. Okay, here all the minus terms, log of 1 minus x. Next one, e power ix is, you know that, cos theta plus I sin theta. E power minus ix is cos theta minus I sin theta. In place of theta we are telling x, cos h theta. E power theta whereas e power minus theta by 2. Sin h theta is e power theta minus e power minus theta by 2. That means like sin theta formula and cos theta formula. These are the main series we have to know. Okay, ma? Next one. Z transforms of some standard functions. Okay, z of 1 is equal to L of 1 equal to like this. Z of 1 equal to z by z minus 1. z of a power n equal to z by z minus a. Z of n, z by z minus 1 whole square. Next one, z of n square equal to z square plus z by z minus 1 whole cube. Next one, z of n into a power n, a into z by z minus a whole square. Next one, z of 1 by n factorial, e power 1 by z. Z of 1 by n equal to log of z by z minus 1. Z of 1 by n plus 1 equal to z into log of z by z minus 1. Z of n square into a power n, a into z square plus a square by z minus a whole cube. Z power minus n equal to 1 by z power n. Z of cos nt, z into z minus cos t by z square minus 2z cos t plus 1. Z of sin nt equal to z sin t by z square 2z cos t plus 1. Both denominators are same. Okay. Next, first we are solving all the formulas. First one, z of 1 equal to z by z minus 1. You know that what is that is z of f of n formula. What is the formula? Sigma n equal to 0 to infinity f of n z power minus n. You know that z power minus 1 equal to 1 by z, z power anything 0 equal to 1. Okay. Now you are writing z, you are finding z of 1. That means you put in place of f of n 1 and expand the sigma. Put n equal to 1, 0. Okay, anything power 0 is 1. Z power, next one z power minus 1. Z power minus 1 is 1 by z. Next one, put n equal to 2. Z power minus 2 is 1 by z square. Like this you expand. This you can write in previous slide we have discussed about the main expansions. Okay, all plus are there. 1 minus, okay, x whole power minus 1. Okay, what is x here? X. So that 1 minus 1 by z whole power minus 1, that we have written like this in the denominator. Okay, and then take LCM, you will get z by z minus 1. This is the first formula. Z of 1 equal to z by z minus 1. Next one, z of a power n, z by z minus a. Again we are taking f of n equal to a power n and write the formula. No? Next one, put in place of f of n. This is the formula. No? Z of f of n equal to sigma n equal to 0 to infinity f of n z power minus n. You put in place of f of n a n. Z of a n equal to sigma n equal to 0 to infinity a power n z power minus n. Okay, and then sigma n equal to 0 to infinity, both powers are same, so we are writing a by z whole power n, and then sigma expanded, put n equal to 0, anything power 0 is 1, put n equal to 1, a by z whole power minus 1, a by z whole power 1, a whole square whole cube, and so on. This is the actual formula. All plus terms are there. No, 1 minus x whole power minus 1, 1 plus x plus x square. In place of x, what is that? A by z. Okay, 1 by a by z whole power 1, you can write 1 by a by z. You take it here, you see here, z, take z LCM, z minus a by z, you write in the reverse order, you will get z by z minus a. So what is the formula? Z of a power n is equal to z by z minus a. Okay, ma? Next, third one, special case. If you take a equal to minus 1, in the above we get z of a n equal to z by z minus a. Okay, z of minus 1 whole power n, z of z minus of whatever the base is there, that you have to write here, z plus z by z plus 1. Z of minus 1 whole power n equal to z by z plus 1. Next one, z of n equal to z by z minus 1 whole square. Third one, f of n equal to n. Here you take again formula, z of f of n equal to sigma n equal to 0 to infinity f of n z power minus n. What is f of n? N. Z of n equal to sigma n equal to 0 to infinity n into z power minus n. Next one, you expand. First put n equal to 0 into z power 0. That is 0 into anything is 0. Put n equal to 1. 1 into z power 1. 2 into z power minus 2. 3 into z cube, like this. Okay. Then you 1 by z, 1 by z square, 1 by z cube, 1 by z power 4. Here we have done. Okay, z power minus 2 is 1 by z square like this. Then you take from this series, you take 1 by z common. That is 1 plus 2 by z plus 3 by z square plus 4 by z cube and so on. Then all the plus terms now 1 minus x whole power minus 1 basically. But here what are the coefficients? 1, 2, 3, 4 like this. Okay, we got. So what is the power 2? So this is the series. Here we have written 1 minus x whole power minus 2 series. Like this we expanded this one. From this expansion we have written this formula. And then take the LCM 1 by z into z minus 1 by z whole power 2 is we have written in the denominator 1 by z into take LCM z minus 1 by z whole square, that means z square by z minus 1 whole square. LCM mean cancel, you will get z by z minus 1 whole square, that means z of n is equal to z by z minus 1 whole square. This is the formula. Okay, no? Z of n equal to z by z minus 1 whole square. Next one, z of n power p equal to minus z into d by dz of z into z of n power p minus 1. We know that z of f of n equal to same formula we are applying now. F of n equal to n power p, where p is the positive integer. Then you substitute z of f of n equal to z of n power p. Sigma n equal to 0 to infinity. In place of f of n, put n power p into z power minus n. Okay. Here you see here n power p you can write plus 1 minus 1 power. Okay, minus 1 plus 1 cancel, again you will get n power p only. So put add plus 1 and in the power you add plus 1 and minus 1 and you separate, right, you separate like this. You will get n power p minus 1 into n z power minus of n plus 1, because z power minus 1 you can write z into z power of minus of n plus. Here also we added 1 and subtracted 1. So here we have written z, extra z, z into sigma n equal to 0 to infinity n power p minus 1, n into z power minus of n plus 1. Okay, next one we have z of f of n equal to basically z of, this is equation 1. Okay, ma? Z of n power, this side we have done. You are going to this side. First you have taken z of n power p minus 1. You put in the formula, put n equal to 0 to infinity n power p minus 1 z power minus n. Differentiate with respect to z. Okay, for this side we have already we have done. This side we have taken this part and differentiating with respect to z also. We get differentiate with respect to z. Here we have written the formula. X power n differentiation is n into x power n minus 1. Z power minus n differentiation is minus n into z power minus n minus 1. That minus common n plus 1. So here d by dz of z power of n power z of n power p minus 1 equal to sigma n equal to 0 to infinity. This is constant. Here, okay, minus n into z power minus n minus 1. So you take minus common, n plus 1 you will get. Okay, this is sigma n equal to 0 to infinity. This you can write n into n power p minus 1. This z power of minus of n plus 1. Okay, ma? This minus we have written this side. Minus of d by dz of z of n power p minus 1. This is equation 2. Okay, right side, left side we have done equations. Then equate equation 1 by subtracting equation 2 in equation 1, substituting equation 2 in equation 1. Okay, we get z of n power p equal to, in place of this, okay ma, we can write this one minus d by dz of z into n power p minus 1 z into this. This is called recurrence formula. Z of n power p we will get minus z into d by dz of z of n power p minus 1. Next one, z of n power p equal to minus z into equation 1. By putting p equal to 1, in the above we get what is that, z of n is equal to minus z into d by the same formula we have taken, z of 1, okay, n power, put p equal to 1. Okay, what is that, 1 minus 1, 0. N power 0 is 1, you will get. Minus z into d by dz of, what is z of 1? Z by z minus 1. You differentiate this z by z minus 1, u by v formula. U v dash minus v, u into v dash by v square. So this is u, this is v, v square. into numerator v into z minus 1 into z differentiation is 1 minus z into z minus differentiation is 1. These two cancel. You will get minus of minus plus z by z minus 1 whole square. Z of n equal to z by z minus 1 whole square. Put n equal to 2 in the equation. Okay, what is that? Put up z of n, we got it. Z of n square is minus z into d by dz of z by z minus 1 whole square. Okay, if here powers more than 1, here differentiation will come. Minus z into d by dz of z by z minus 1 whole square. That means you simplify, you differentiate and simplify, you will get z square plus z by z minus 1 whole cube. Similarly, put z p equal to 3, z of n cube equal to 2 times, here 2 times differentiate this one. And then simplify, you will get this. Okay, this is the z of n and z of n square formulas. Next one, z of n into a power n equal to az by z minus a whole square. We know that z of n formula, sigma n equal to 0 to infinity f of n z power n. Here what is f of n? N into a power n. Substitute here in place of f of n, n into a power n. And then what is that is expand n into a by z whole power n. Put n equal to 0, 1. 0 into anything is 0. Put n equal to 1. 1 into a by z whole power 1. And then whole power 1. Okay, ma'am. Minus basically a by z whole power n. Next one, a by z. 2 into a by z whole square. 3 into a by z. So that these are the a by z, you take it common, 1 plus 2x plus 3x square, like this you got it. Then you can write a by z 1 minus x whole power minus a by z LCM, and you write in the numerator, cancel, you will get, this is the formula we for this series we applied this formula, and then you will get cancelled. Finally what you got, az by z minus a whole square. Okay, where z of n into a power n is there, now you will get az by z minus a whole square. Always you have to remember this formula. Whatever the z of they have given, you come, okay, you come here and write the formula and substitute in place of f of n. Okay, whatever they have given in the z of function, okay, that you substitute here and expand it, apply which formula is suitable for that, and then simplify, you will get final answer. This is the way you have to simplify the formulas. Seventh one, z of 1 by n factorial. We know that again, you know that z of f of n equal to sigma n equal to 0 to infinity f of n z power minus n. Substitute in place of f of n 1 by n factorial. Expand it. Here, you know that 0 factorial, 1 by 0 factorial, 1 by 1 factorial, 1 by 2 factorial, z power minus z. These are all, you know that. Okay, now we are expanding. 1 minus z power minus 1, 1 by 2 factorial, z power minus 3 by 3 factorial, 4 factorial. This you can write, z power minus 1 is 1 by z by 1 factorial, 1 by z by whole square by 2 factorial, 1 by z whole cube by 3 factorial. Like this you can write. Now you see here e power x, what is the series for e power x is 1 plus x by 1 factorial, x square by 2 factorial, x cube by 3 factorial, and so on. Same, you just apply this formula for the series. What is the x is here 1 by z, that you can write e power 1 by z. What is the formula is z of 1 by n factorial equal to e power 1 by z. This is the same process for every formula, you are applying the same process. Okay, my next one, z of 1 by n equal to log of. We know that the same formula, and apply in place of f of n, you put 1 by n and expand this. Put n equal to 0, put n equal to 1, like this, expand it, and then write 1 by z whole square plus, like this, and then x plus x square by 2. There are no factorials. When the denominator there is no fact, if the factorials are there, you have to immediately you have to recall the formula is e power formula, exponential formula. But here there are no factorials, but square term, cube term, like this in the numerator, all the square terms are there. Square, cube, like this. This is the 3. Sorry, you write, this is when you are writing your notes. Simple mistake is there. 1 by z whole cube here, 1 by z whole power 4. Okay, you rectify this, and then what is the series is this log z, log of 1 minus x equal to log of minus of log of 1 by z inverse. That is minus log of 1 by 1 by z. Simplify, you will get this. Reverse order, z by z minus 1. Log of 1 minus x minus equal to z of 1n equal to z of 1 by n equal to n by z log of z by z minus 1. Next one, ninth one, z of 1 by n plus 1 equal to n into log of z by z minus 1. Same formula, same applying the formula, and we are expanding where n equal to 0. 1 by 1 into z power 0 is 1. 1 by 2 into z power minus 1, 1 by 3 into z power square, like this. And then 1 plus 1 by 2 into 1 by z, 1 by 2 into 1 by z square, 4 z2. You take, here, z power 1 is there, no? Here 1 factorial or 1 has to, in any series has to there. But here z square is there, no? 3 is there. For that, we are multiplying and dividing z term. Okay. That means z into z multiplication and divided by 1 by z. 1 by z and then z common. 1 by z into 1 by 2 into 1 by z square. 1 by 3 into 1 by z cube. 1 by 4 into z power 4. That you write in the numerator. Then this is the minus z into, this is x plus x square by 2 x cube by 3. Therefore log apply. Log of 1 minus 1 by z. Z into log of z by z minus 1. That means z of 1 by n plus 1 equal to z into log of z by z minus 1. Okay, ma? This is the 9th formula. Unit step function or z transform of discrete unit step function. The unit sequence or function is defined as f of n equal to 0. That function value is 0 when n less than 0. When f of n equal to 1, this is called step function. Okay, n greater than or equal to 0. Positive integers, then you take it 1. You write the formula, sigma formula. Sigma z power minus n equal to z by z minus 1. And properties of z transforms. Okay, this is the actual formula. This we can write z of 1 equal to z by z minus 1. And then linear property. We know the linear property. If a comma b are any constants and f of n and g of n are be any discrete function, then a linear property already we learned in the Laplace also. Z of a into f of n plus b into g of n equal to, you can write the constants outside. A into z of f of n, b into z of g of n. We know that. Okay, write the sigma formula, and then for g of n also we can write the formula, sigma formula, and then both add it. Z of a into f of n plus b into g of n equal to sigma n equal to 0 to infinity a f of n plus b g of n into z power minus n. You separate these two. Sigma n equal to 0 to infinity a into f of n z power minus n. Sigma n equal to 0 to infinity b into g of n into z power minus n. And then write the constant, because this is the sigma. That means n is the variable. A is constant. You write a and b outside. But instead of this one and this one, you can write the z of whatever the function is that you write here. Z of f of n, here z of g of n. Finally, you can say the linear property is z of a into f of n plus b into g of n equal to a into z of f of n plus b into z of g of n. That means that constant you can write outside. This is called linear property. Change of scale property or damping rule. That means f of z of f of n. If z of f of n equal to f of z, then z of damping rule or changing property, scale property is n a power minus n multiplication factor into f of n equal to f of a into z. Final answer. We know that. Write z of f of n formula. Okay, after that you write z of a power minus n into f of n. You substitute here a power, wherever f of n is there, that is whatever they have given the function, that you substitute here. A power minus n into f of n, z power minus n. Sigma n equal to 0 to infinity f of n. These two terms have powers are same. So az whole power minus n. So that this is, you see, you compare the actual formula, sigma n equal to 0 to infinity f of n z power minus n. whatever here z is there, that you are writing here f of z. That means z of f of n equal to f of z you are writing. That means z power n. In place of z, what is there here? Az. So that you are writing f of az. Z of f of n equal to z of f of az. Finally, z of a power minus n equal to a power minus n into f of n equal to, what is that? The answer is f of az. This is called damping rule. Okay, ma? Yes. Thank you. Next class, we are doing, I'll explain the problems about these damping rule and the total formulas. Okay.